Lesson 8.3, Introduction to Solving Systems of Equations by Elimination. To solve by elimination, we're going to use our friend LOAS, L-O-A-S, LOAS. Here's what LOAS stands for. It will help us to remember the steps to solve by elimination. L stands for line up. We need to write the system so that the like terms with the same or opposite coefficients are aligned. So basically we need our x terms stacked, our y terms stacked, the equal signs stacked on top of one another, and then the constants stacked on top of one another. So if the system does not look like that, we need to move the terms around so that the terms are lined up so that they're stacked. So that's L. O is for opposites. We need to get opposite terms. And so if necessary, we need to multiply at least one equation by a constant, which is just some number, multiplied by a number so that we result in two equations that contain opposite terms, like 2x and negative 2x. Those would be opposite terms, or negative y and positive y, or negative 4x and positive 4x. We need to get opposite terms. So line the equations up, get opposite terms. A is for add. We add the equations, and by adding the equations, we will eliminate one of the variables. And that's where this method gets its name, elimination. We're going to eliminate one of the variables so that then we can solve for the remaining variable. The S is for substitute. We're going to substitute the value from step 3 when we added the equations together and solved for that variable. We're going to substitute that value into one of the equations to solve for the other variable. And then once we have our x and our y, we write the solution as an ordered pair. So let's do two examples, example 1a and example 1b. So 1a is right here. We have this system. Okay, this bracket just says that these are a system. This equation works with this equation. Let's call the top equation equation 1 and the bottom equation equation 2. Okay, so first off, L, are these equations lined up? Well, yes, they are, right? I have x's stacked, y's stacked, and constants stacked on top of one another. So I go to step 2, which is O. Do I have opposite terms? Well, I do with my x's, right? 2x and negative 2x, those are opposite terms. Opposite terms, when added together, will cancel each other out. And so I already have opposite terms. I'm going to go to step 3. I'm going to add these equations together. So I'm going to put a little plus sign here for add, draw my equal sign. I'm going to add these equations. What is 2x plus negative 2x? Well, since those are opposite terms, they cancel one another out, right? And so that variable x has now been eliminated. That's where we get the name elimination from. What's y plus 3y? That would be 4. 4y. I bring the equal sign down. What is 8 plus 16? Well, that is 24. Okay? So I have 4y equals 24. Well, if 4y equals 24, what does y equal? How would I solve for y? Well, I would divide by 4. Divide by 4 on both sides so that those 4 simplify, and so y is equal to 24 divided by 4. That is 6. Okay? So I have half my solution. I know what y is. How am I going to get x? Well, after I've added the equations together and solved for the remaining variable, which in this case was y, I substitute this value for y into one of the equations. You may be asking yourself, which equation should I put it into? Well, it doesn't really matter. You can put it into equation 1 or put it into equation 2. Either way would be correct. Now, it may be easier to, when you plug in y, to pick an x that is either a coefficient of 1 or a coefficient that is positive. That way when you solve for x, you're dividing by a positive number. Okay, so I'm going to pick this equation since x is a positive 2. If I were to pick the second equation, x would be a negative 2, and so I know that eventually I would have to divide everything by negative 2. So let's pick equation number 1. I'm just going to copy equation number 1 down here. Equation 1 was right here. It's 2x plus y equals 8, and now I know what y is. I can plug y right there. I can plug it in. So I have 2x plus y, which is 6, equals 8. Now I just solve for x, move 6 to the other side by subtraction. Those cancel. 2x equals 8 minus 6 is 2. Solve for x by dividing by 2. So x equals 1. Okay, so now I have an x and I have a y. I am now ready to write my solution as an xy ordered pair. Like the alphabet, x comes first, that's 1. Put a comma and then put the y value, which is 6. So 1 comma 6, and ordered pairs are always put in parentheses. So 1 comma 6 is my solution for 1a. Okay, let's go to example 1b. 1b. In this system, I have x plus 4y equal 13. Let's call that equation number 1. And x minus y equal 3. Let's call that equation number 2. Remember, I'm following low as here. Low as. Line up, opposites add, substitute. So for L, are my equations lined up? Are they stacked? Well, my x's are, my y's are, my constants are. They are stacked. So this system is already lined up. So go to O. Do I have opposite terms? Are x and x opposite terms? Nope. If I add x and x together, I'm going to get 2x. What about 4y and negative y? Are those opposite terms? No. So I don't have opposite terms. What am I going to do? Well, I need to get opposite terms. How do I get opposite terms? If you look on your paper, it says if necessary, which this would be a case where it's necessary. If necessary, multiply at least one equation by a constant, which is just some number. So I could be multiplying both equations by a number, but in this case, I would really only need to multiply one of the equations by a number. Let's look at our variable x. I have x and x. What would be the opposite term for x? What could I add to x so that when added to x, the terms would cancel? Well, if I add x and negative x, those terms would cancel, right? So how can I get this term to be negative 1? Well, what if I multiplied x by negative 1? What would negative 1 times x be? That would be negative x, right? But I can't just multiply that term by negative 1. I have to multiply everything in the equation by negative 1 so that I'm not changing the equation. So what we're going to do here is we're going to multiply this whole entire equation by negative 1. So I'm going to put negative 1. I'm going to put the whole equation in parentheses. I'm multiplying the entire equation by negative 1. So this top equation, equation number 1, is going to stay exactly the same. Equation 1, I'm just going to copy it down here, will still be x plus 4y equal 13. I'm just copying that down. Equation 2 will change because I am multiplying every term in the equation by negative 1. So like I normally would do if I were to distribute, what is negative 1 times x? That is negative x. Negative 1 times, what's this term? This term isn't y, this term is negative y. So what's negative 1 times negative y? That would be positive y. I bring the equal sign down. What's negative 1 times 3? Negative 1 times 3 is negative 3. Now, since I multiplied this entire equation by negative 1, the resulting equation now results in opposite terms. So my equations are lined up. I now have opposite terms. So now I'm on step 3A. I'm going to add these equations. I'm going to put a little plus sign here to add these equations. What is x plus negative x? That's 0, right? They cancel each other out. They eliminate. That's the whole reason I multiply by negative 1, is so that I'll have opposite terms that eliminate one another. What's 4y plus y? That is 5y. Bring the equal sign down. 13 plus negative 3, that's going to be 10, right? Different sign, subtract, keep the big guy. 5y equals 10, so what is y? Well, divide by 5, divide by 5, those 5 simplify, and so y equals 10 divided by 2, which is, 10 divided by 5, which is 2. So now I know that y is 2. So if I know y is 2, how am I going to get x? Well, I sub in, right? This would be the last step. Sub in this value for y, sub in this value for y into one of the equations. Does it matter which one? Nope, it does not. I could sub it into equation 1 or equation 2. I'm gonna pick equation 2. Original equation 2. Original equation 2 was this right here. I'm just going to copy it down right here. The original equation 2 was x minus y equals 3. That was the original equation 2. And now I know what y is. I know y is this. I know y is 2. So I'm going to plug y, I'm going to plug 2 in for y. So x minus y, which is 2, equals 3. Now I'm going to solve for x. I move 2 to the other side by addition, Those twos cancel, so x equals 3 plus 2, which is 5. I am now ready to write my solution. I have an x and I have a y. So like the alphabet, I put x first, which is 5, then a comma, and then I put the y value 2. X and then y, like the alphabet, x and then y. So ordered pairs are always put in parentheses. The solution here is 5, 2. 5, 2 is the solution.